All right, so this is your video for assignment number 3, which is solving quadratic equations by graphing. So we've already graphed equations that are of this form, but now we're going to try to solve this equation. So we want to know what x value can I stick in for these x's here and here so that the value gives me a value of 0. So maybe like if I plug in 1 for each of these x's, I get a value of 0. Maybe it's 2 or maybe it's negative 2. But there has to be at least one x here that I plug in for both of these x's that makes this equation equal to 0. Well, there's several ways that we're going to learn to solve this equation, but today we're going to solve it specifically by graphing them. And so what we're going to do is graph a similar, it's not going to be equal to 0. We're going to graph something that looks like this. Y equals 2x squared minus 8x plus 6. So it's the similar equation, but we're going to be trying to figure out when does the y in our graph equal to 0. So we're going to go through the process, the same thing that we did yesterday when we were just solving these equations, but we're looking for something specific today, and that's when the y value is equal to 0. So let's start graphing this the same way that we did yesterday. And the first thing we're going to do is find the vertex. And if you remember yesterday, we learned how to find the vertex by using this equation, negative b over 2a. This is going to be an equation that we're going to use a lot in the next few days in order to graph equations that look like this. So our b value is negative 8. So we're going to have negative b, which is positive 8, because it's a negative 8 here. So a negative 8 is positive 8, over 2 times the a value, which in this case is 2. So that's equal to 8 over 2 times 2, which is 4. And then 8 over 4 is 2. So when we make our table of values, we're going to start with the vertex, and that's what we put our rectangle around. We're going to start with our vertex at 2 something. In order to figure out what the something is, we're going to have to plug 2 back into the equation. So for example, we're going to have 2 times 2 squared minus 8 times 2 plus 6. So 2 squared is 4. 4 times 2 is 8. Minus 8 times 2 is 16 plus 6. And 8 minus 16 is negative 8. And negative 8 plus 6 is negative 2. So if I'm graphing this equation, I know that on my graph, my vertex is at the point 2, negative 2. And 2, negative 2. I go 2 to the right and 2 down. This is my vertex. So we also know that the axis of symmetry goes through the vertex. We should also realize by looking at the equation, the a value is positive. That means it's going to open up. So I don't know exactly where it's going to open or how fast it's going to open at this point, but I do know that it's going to open up, and that's my vertex. So I'm going to plug in other numbers around 2, like 1 and 0 and 3 and 4, into my original equation here to figure out what the y values are. So let's start with 0. Let's start with 0 here and plug in a 0. I think we can do this without actually writing it out. 0 squared is 0, times 2 is still 0. Minus 8 times 0, that's 0. So we have 0 minus 0 plus 6, which is 6. And if I were to plug in 4, I would have 2 times 4 squared minus 8 times 4 plus 6. Well, 4 squared is 16, and 16 times 2 is 32. Minus 8 times 4, well, that's 32 plus 6. And 32 minus 32 is 0, plus 6 is 6. And that makes sense because we know from yesterday that those two values always match up. Same thing with these two values. Let's just see what we get when we plug in a 1 here. If I plug in a 1, I think we can do this without writing it out. Let's just try it here. 1 squared is 1, and 2 times 1 is 2. So that value is 2. Then if I plug in a 1 here for this x, 8 times 1 is negative 8 plus 6. 2 minus 8 then is negative 6, and negative 6 plus 6 is 0. So when I plug in a 1, my y value is a 0. That's going to be significant. We'll talk about that here in just a little bit. That should also match what we get when we plug in a 3. Let's just make sure that it really does. If I plug in a 3, it's going to be 2 times 3 squared, and then minus 8 times 3. So we have minus 8 times 3 plus 6. 3 squared is 9. 9 times 2 is 18. Minus 8 times 3 is 24, and then plus 6. And 18 minus 24 is negative 6, plus 6 does give me a value of 0. So let's just look at our table of values here and compare it to what we have on our graph. We already graphed the point 2, negative 2. So then we have the point 1, 0, which is here. We have the point 3, 0, which is here. We also have the point 0, 1, 2, 3, 4, 5, 6, which is up here. And then 4, 6, which is up here. And my parabola looks like this. So where are the y values equal to 0? Well, you can see we have two of them. Here, when I plug in an x, a 1 for x, I get a y value of 0. And here, when I plug in a 3 for x, I get a y value of 0. We can also look at the graph, and the y values that are equal to 0 are along the x-axis. So here's where y is negative 2, negative 1. Here's where the y values are 0, and it's at two places, at 1 and 3. And so my solution to my original question, which was to solve this equation, is that x is equal to 1 or x is equal to 3. And those are my two solutions. And probably the easiest way to look at this is that's where it crosses the x-axis, at 1 and at 3. It's a lot of work to solve that one equation, but these equations are going to be a little bit more complicated than the ones we've solved in the past. Let's take a look at another one. And what I would like to do on this one is I'd like to see if you can solve this one on your own first. Stop the video, see if you can write this problem down, solve it on your own, and then start the video and see if you were correct. And if you're correct, that's great. If not, then you'll know how to do it once we do it together. So try that right now. Pause the video, see if you can solve it. And I'm going to assume that you did that. And if you didn't do that, then just make sure you go along and do it with me now. I'm going to solve it the same way we did the other example number 1. And so what I'm going to do is write this equation like this. It's negative x squared minus 2x plus 3. But instead of equaling 0, I'm going to make it equal to y. And I can either put the y over on this side or I can put the y over here. And usually when we graph them, it usually starts with y. So I'm going to put the y over on this side. I'm going to simply graph this equation. First thing I'm going to do is find the vertex. And I'm going to find the vertex, again, using negative b over 2a. And so I'm going to have my negative b value, that's negative 2, which is positive 2, over 2 times a, which is negative 1. Well, that's 2 over negative 2, and 2 over negative 2 is negative 1. So when I make my table of values, I'm going to have negative 1 and then something for my vertex. So I'm going to plug in negative 1. I'll probably plug in 0 and positive 1 and negative 2 and negative 3. And those can go in any order there. So I'm going to plug those values in. And I'm going to start plugging in negative 1. So we have negative and then negative 1 squared minus 2 times negative 1 plus 3. So negative 1 squared is 1. But then this negative is going to make it negative 1. Negative 2 times negative 1 is positive 2 plus 3. Negative 1 plus 2 is 1, and 1 plus 3 is 4. Should have left more room there, but it's negative 1, 4. That is my vertex. So when I graph this equation, I want to have a point at negative 1, 1, 2, 3, 4. And this point is my vertex. Here's my axis of symmetry, and I'm going to have other points around there. One thing we should know is that this parabola is going to open down because the a value is negative. My y-intercept is at 3. And so actually, because my y-intercept is at 3, I can put a point there. I know that that's going to be a point. My y-intercept is always the same as my c value. Okay? And so we want to figure out when is this going to cross the x-axis. And wherever it does, that's when it's equal to 0. So let's start plugging in some other values. If I plug in 0, This is going to be 0 because 0 squared is 0. 2 times 0 is 0. So I have 0 minus 0, which is 0, plus 3, which is 3. And that makes sense that this point is on the graph because that's my y-intercept. It's the point 0, 3. Now, it would make sense that I would have a point over here that matches that point. And that would be negative 2. Hopefully, when I plug in negative 2, I also get 3. Let's just try this out real quick. Negative 2 squared is 4, but then the negative is going to make it negative 4. And then negative 2 times negative 2. Negative 2 times negative 2 is positive 4, and then plus 3. And negative 4 plus 4 is 0. 0 plus 3 is indeed 3. So we have a parabola that is starting to form. We know it's going to open down. It's going like this. It's not yet equal to 0. Let's try plugging in 1. If I plug in 1 here, I have 1 squared is 1, but then the negative is going to make it negative 1. Negative 2 times 1 is negative 2, and then plus 3. So negative 2 minus 2 is negative 3, and negative 3 plus 3 is 0. So there is a point at negative 1, 2, 3, 0. And if I were to plug in negative 3, I would indeed get 0 again. Okay, so my parabola looks like this. It does open down like we thought. The y-intercept is at 3. The vertex is at negative 1, 4. If I were to write an equation for the axis of symmetry, it would be x equals negative 1. But my solution to my original question, which is when is this equal to 0? Well, it's going to be equal to 0 at 2 places. One of them is at 1, and one of them is at negative 3. So x equals negative 3, or x equals 1. And that is my solution. Hopefully that's what you were able to come up with on your own. Now, let's take a look at examples 3 and 4 here. Something different happens. In our first 2 equations, we had 2 solutions because the parabola hit the x-axis in 2 different places. That doesn't happen in example 3 or example number 4. So let's talk about this. I'm going to rewrite this as y equals negative 2x squared plus 12x minus 18. Now, if you want to try this on your own, I would encourage you to do that. If you could just pause the video and try to figure out what the solution is first on your own, and then you can play the video again and see if you were correct. Why don't you do that now? Assuming that that is what you have done, I'm going to start graphing this equation again by finding the vertex, which is negative b over 2a. So in this case, it's going to be negative 12. That's my b value over 2 times negative 2. 2 times negative 2 is negative 4. And so negative 12 divided by negative 4 is 3. And that is my x-coordinate for my vertex. So I'm going to make my table of values over here. And this is going to be the point 3 something. That's my vertex. I'm going to plug in numbers less than that and more than that. And I'm going to make my graph that looks like this. Here's 1, 2, 3. My axis of symmetry is going to go along that x equals 3. So it's going to be somewhere along this line is my vertex. Well, let's figure out where the vertex is by plugging in 3 into my original equation. I'm going to have negative 2 times 3 squared plus 12 times 3 minus 18. Well, 3 squared is 9, and 9 times negative 2 is negative 18. 12 times 3 is 36, and then minus 18. Well, negative 18 plus 36 is 18, and 18 minus 18 is 0. So my vertex is actually at the point 3, 0. Now this is an interesting one because we know the parabola is going to open down. I know the y-intercept is going to be way down at negative 18. If I were to plug in 2 or 4, I would actually get negative 2. In other words, I'm going to have a point here, and I'm going to have a point here. And this parabola is going to open down like this. How many times does it hit the x-axis? Well, the only place that it hits the x-axis is right here when x is 3. So this only has one solution. There's only one number that I can plug in for x that makes this equal to 0, and that is when x is 3. And that is my solution. So on example 1 and example 2, there were two solutions, because if we look back at example 2, there were two places that it hit the x-axis. So we had two solutions, -3 and +1. Example number 1, we also had two solutions, because there were two places where it hit the x-axis, and that was at 1 and 3. But in example number 3, there's only one solution, because the graph only hits it one time. Alright, so let's take a look at example number 4, and this is the last graph that we're going to do together. Something interesting happens on this graph, just like in example number 3. We would start by writing it as y equals x squared plus 2x plus 6. And we would find the vertex by using -b over 2a. And again, if you want to try this on your own first, it'd probably be a good idea to do that. And then when we went over it together, it would actually make more sense to you. Why don't you pause the video, try it on your own, see if you can figure out what the solutions are, and then you can play the video when you're finished. Alright, assuming that you've done that, let's continue on here. We were going to find the vertex by taking -b over 2a, and in this example, it's going to be -2 over 2 times 1. And -2 over 2 times 1 is 2, and -2 over 2 is just -1. So that is the x-coordinate for my vertex. So I'm going to put that right here. And I'm going to plug in things like maybe -2, -3, and then 0 and 1. But my vertex is right here in the middle. And if I want to find my y-coordinate, I'm going to have -1 squared plus 2 times -1 plus 6. -1 squared is 1. 2 times -1 is -2 plus 6. And 1 minus 2 is -1 plus 6 is 5. So we know the graph is going to look something like this. Here is -1, 1, 2, 3, 4, 5. Here's that point. Here's my axis of symmetry. Does this parabola open up or down? Well, you can look at the original equation. The a value is positive, which means this parabola is actually opening up. And you can tell my y-intercept is at 6. So if I were to plug in 0, I would get 6. -2 would also give me 6. I really don't need to finish this because my parabola is going to look something like this. So where are my solutions? Where does it cross the x-axis? Well, you can see here that it doesn't cross the x-axis, which means there isn't a value for x that makes this equation equal to 0, which means there's no solution. And so there are three different things that could happen when you solve these equations. You could get two solutions like we had in example 1 and example 2. You could have one solution like we had in example 3. And then you could have no solutions like we have here in example number 4. And actually, you can tell the number of solutions simply by looking at the graphs. You don't have to write this down, but let's take a graph that looks something like this. How many solutions would this one have? That would have none because it never hits the x-axis. If the graph looked like this, and it hit it just once, this would be an example of something that would have one solution because it only hits the x-axis one time. And then if I did something like this, and it crossed it twice, that would be an example of a graph that has two solutions. And so now you are ready to start assignment number 3. So you can open up My Big Campus, you can open up assignment number 3, and start graphing the equations that are in assignment number 3.